In previous lectures, we have studied various sensors like range sensors. In that, we have seen ultrasonic sensor. Okay, in ultrasonic sensors, there are two units like one is a transmitter and one is the receiver. With the help of transmitter, we can send the sound waves, and with the help of the receiver, we are collecting the sound waves. Depend upon the okay distance, the time required to transmit and receiver. Okay, we can find the distance in between. This one already we have discussed in last lecture. Ultrasonic sensors again, as well as we have seen the advantages and disadvantages of these ultrasonic sensors. Next, after that, we have started the infrared sensors, or it is popularly known as the IR sensors. These are sensors, again, it consists of two LED lights, like it is one consists of IR emitter and second one is the IR receiver. From one LED, we can transmit the infrared and it will strike to the object, and with the help of IR receiver, we can collect the IR sensors or the infrared, and depend upon the traveling time, we can calculate the distance of any obstacle or object. Okay, again, last time we have seen advantages, disadvantages, as well as we have seen the video related to that, how actually it is works. Okay, next we have seen the microwave sensors. Microwave sensors, it is similar function of our ultrasonic sensors, but in this we are sending some microwaves, and that depend upon the sending and receiving waves. Okay, we can find the obstacle or the object distance. Okay, as well as we have seen some of the disadvantages of the microwave sensor. Okay, this part also we have covered. Laser sensor also we have seen last time. We are also working of that laser sensors, how actually it works. Might be we have not seen this video, laser sensor video. Just I will play that video. Just watch it carefully. How actually these kinds of you will find the laser sensors. You can find such kinds of arrangement inside that. Okay, you can see now object in front of that laser sensor, it will detect and it will indicate blink the light band if obstacle in front of the lasers. Okay, we have seen laser sensor. Now we will move towards next part of our chapter. It is nothing but vision sensor. Okay, 2-3 more sensors are remaining. We'll finish that sensors today and we'll start the new part of this second unit. It is nothing but actuator. Okay, types of actuator. and working principle of that actuator. Now, vision sensor might be, okay, it is required in the robots. Why it is needed this vision sensors? का गरजेचं आहे आपल्याला रोबोटिक्स मध्ये? Similar to our eyes, okay, human also need the vision sensors. Okay, vision sensors is nothing but we can say that our eyes are a vision sensor of human body. Okay, आपले जे काही human. Rohit, have you written something in screen?
Sir, by mistake, sir.
Okay. In vision sensor, okay, in human also, eyes are the vision sensor of human, and with the help of eye, we can detect any object, or we can say that to differentiate the, okay, metals, non-metals, or surrounding. Okay, we need the eyes. Okay, आपल्याला आयची गरज असते. त्याच पद्धतीनं, okay, robot also need the eyes, okay, and that eyes is nothing but our vision sensor. And a vision sensor, we can simply define it is one type of camera. Okay, vision sensor म्हणजे काय तर एक टाईपचा कॅमेराच आहे. The it vision sensor, it works on the principle of our camera. Okay, first it will detect the, or we have to take the picture of that one, and depend upon that picture, okay, we can convert into the electrical pulses, and it will stored in somewhere. Okay, now vision sensors, these sensors are used to recognize the three-dimensional object in the form of picture. Okay, एखादा three-dimensional object असेल तर तो recognize, or the to differentiate, for that we need the vision sensor. These sensor also called as robot vision, machine vision, or it is also known as the artificial vision. Okay, next, vision sensors. How we can define now? Vision sensors have many parts to work, are usually composed of a video camera, display, interface, and computer process. Means it consists of different parts. Okay, start with the camera, display, interface, and the computer processing. Means inside that, okay, first we have to take the pictures, or the, we can say that video camera. In that video camera, number of pictures are clicked, and that are in a sequence. Depend upon that sequence, okay, it will displayed in the computer, and that computer will process on that, and we can see that pictures or video of that one. Next, vision sensors require these components to automate industrial process and decisions, record a measurement, initiate pass fail decision, observe the quality of analyzable product. Okay, next one is the some vision sensor also contain an integral process. These are called smart cameras. Okay, again, these processed image is provided to our controllers, and that accordingly, okay, controllers whether it will pass or fail that object, it will detect, and that detected object, whether it will move further or it will pick up from that place. Okay, it will decide accordingly. Okay, next one is the vision sensors use images to determine the presence, orientation, and accuracy of surrounding object. Okay, means mostly the vision sensors is used in food processing industries, okay, to check whether the object orientation is correct, or the whether that product is correctly packed or not packed. Okay, we can check with the help of this vision sensor. Means some difficulties inside that product, then he will remove that vision sensor, will capture that image, and he will inform to controller, and accordingly robot will remove that product from the conveyor. Next, vision sensors uses a combination of both image acquisition and image processing, and multiple point inspection can be done using a single sensor. Okay, means only with single sensor we can do all image processing part, acquisition part, okay, with that sensors only. Next, vision sensor also provide a data interchange between the video camera and the computer processing unit. Okay, next. Okay, there are two types of image capturing. Okay, one is the monochrome model and second one is the color model. Okay, how that monochrome model image capturing process is occurred, now we will see. In monochrome model, the image is captured by the camera, passes through a lens, and is covered into a electrical signal using a CMOS compatible light receiving elements. Okay, means in that CMS means element segments. Okay, that segments we can do with the help of this monochrome model, and that model is generated on in the form of electrical signals. Okay, the might be, okay, in the monochromatic light only single wavelength light is passed, and depend upon that signal, okay, that image is generated. Might be you have seen in the experimental stress analysis. Okay, in that you have seen experiments. Okay, some of experiments that monochromatic, if you pass the monochromatic light in the optical plate, then you will see the fringe pattern. Okay, one specific fringe pattern, either in a dark mode, okay, or the light mode. Okay, similarly on the same principle, here also we can get the single wavelength light, and depend upon that the image will be generated, and the output will be some electrical signal. The brightness and the shape of object are the determined by its intensity from each pixel from the light receiving element. Okay, means depend upon the intensity of light. Okay, that monochromatic light, depend upon that intensity, the it will detect the shape and size of the object. And last one, the contrast between the white and black region can be identified, as can the shape orientation and brightness. Okay, now only we have discussed, depend upon the white and black pattern, it will generate similar to your experimental stress analysis lab, in that you have seen in photoelastic model, the black and the white fringes are occurred. Similar fringes you will find, and depend upon that only it will generate the shape and orientation of the object in monochromatic model. And the second one is the color model. In color model you will find different colors like a red, green, blue. Okay, there are different colors with different intensity, and depend upon that it will generate the image. The received light is separated into red, green, and blue colors. This is followed by determining the intensity of each color, even if the color have minimal intensity difference. Okay. Next, the object are the determined by their color difference rather than their intensity. Okay, means the shape and size or orientation, we can say that it is defined with the help of here only in the form of white and black regions, but here you will get the different colors to differentiate or the to find the shape and orientation of the object. Like you the we can say that in monochromatic model you will get the black or the black and white image, and in color model you will get the colored object. Okay, next, some of the steps it is performed while sensing and the processing. Okay, एखादी इमेज सेन्स करत असताना एक डेफिनेट प्रोसेस असते, ती आपण प्रोसेस बघूया आता कुठली प्रोसेस असणार आहे त्या ठिकाणी. In that, the first one is the image acquisition. Okay, in that the image, okay, which image we want to, okay, we want to define, or we have to take the picture of that image. Okay, we have to select that, depend upon that image. Okay, we have to click that image. After clicking, we will move towards image enhancement. Means after clicking that, okay, it will move to the, okay, enhancement of that image. Means some blur part will be there, then in that image enhancement, it will increase the, okay, pixel, and depend upon pixel, okay, it will generate the greater size of image. Next, image restoration. Next, image color image processing. Again it will add the some colors as per the, okay, surrounding. Wavelet and multi-resolution processing, comparison, morphological processing, segmentation. Segmentation means it will convert into small pixels. Again, representation and description, object recognition and knowledge base. Means object recognition, it is done at last, and that it is done with the help of controller, and that controller will uh, provide that, okay, which object, that object name which is provided to our robot, and that robot will decide whether we have to move that object further, or we have to remove from that. Okay, these are the some process. From that process it will move, and accordingly object that recognition it is done, and the information is provided to the robot. Okay, next we'll see the how actually it is done. So with one video.
Thousands of companies across the globe produce and transport millions of products each day. Many of these products would not be possible without machine vision to help guide,
You can see,
inspect,
okay, this one is the vision sensor.
gauge, and identify their products. Cognite's vision sensors and 2D and 3D vision systems are all powered by advanced algorithms and robust technologies like PatMax for object location, image formation, 3D vision and measurement, barcode reading, OCR, advanced color tools, and deep learning tools. These industry-leading solutions solve simple to highly complex applications, like pick-and-place robotic guidance, validating dimensions of auto parts, ensuring caps are sealed on detergent bottles, and verifying characters printed on food packaging. Cognite's vision systems are built with the manufacturers of today and tomorrow in mind. Rugged housings deliver top performance, even in harsh industrial environments. Modularity offers field customizable solutions for your specific applications. And intuitive software enables fast and easy setup and deployment. With industry-leading technology and world-class vision solutions to help optimize quality, maximize throughput, and minimize waste. For more information, visit cognex.com/machine vision.
Welcome to our Vision Campus. Our topics for today: what is a vision systems are used? Processing equipment, identification. Portion of this miracle tool is working around the clock on image identification, processing, and interpretation. Yet something that the brain seems to handle effortlessly is a real challenge for machines. Ultimately, all artificial vision systems are trying to achieve the image identification performance of the brain for a very special application. Nowadays, these systems work astoundingly well, all at high speeds and completely inexhaustibly. I would like to provide you an example from the food industry to illustrate what I mean. When it comes, it's supposed to have the same shape of the customers. Production errors. Those are just one of the technology. With it, utilization of different types of camera, line known as the line in its entirety, comparable with the flatbed scanners. This process is a bit comparable with a flatbed scanner that
Now you
also
can see
records
in
the image
conveyor
line by line
that
and then forwards it to the
processing,
computer.
controlling.
It works well when a conveyor belt is used to move the objects to be inspected. If, for example, I want to check a web of cloth for tears or faults, then a line scan camera is the right choice. An area scan camera has an area sensor and records the large area image simultaneously in its entirety. The process is fast, but if the object is moving quickly, such as on a conveyor belt, there can be motion blur. Let's imagine I want to check the size and shape of our cookie. An area scan camera is a good choice for this. Lenses are very important accessories for vision systems. Every camera needs a lens with certain properties in order to choose the appropriate field of view and to image the object in clear focus to the sensor of the camera. Depending on the application, cameras are equipped with different lenses to fulfill the requirements of the inspection task. To record a good image of our cookie for inspection, we need a light source to illuminate the cookie. Let's presume we want to decorate another cookie solely with red chocolate buttons. If the task is simply to differentiate the blue ones from the red ones, for example, then a red light should be used. The red buttons reflect the red light completely and thus appear to be very bright, while the blue ones primarily absorb the light and appear as dark. The light source is thus another important component of a vision system. For this inspection task, a monochrome camera is fully sufficient. Color cameras should be used in situations where multiple colors are being checked, such as for checking the print on the cookie packaging. Within the camera, the brightness information for our cookie acquired by the sensor is processed into an image. That image data is then transmitted to the computer for analysis via the interface cable. Everyone wants compact solutions that are as simple as possible. To accommodate this, are to opt for into the camera's indicated a lens, light source, interface, computer, and software makes it easy for the user to monitor the production process and intervene when faults arise. When working with fully automated production monitoring, the vision system can also send control signals to a machine to sort out the bad cookies. Our cookie example is an application involving quality control in the food industry. Vision systems are used in many other areas, such as medicine, traffic control and monitoring, and in the retail field. I hope I've been able to shed some light on the topic of vision systems, components, and potential applications. Thanks for watching.
Okay, I hope you understood. These are the some processing elements. Okay, we will move to us. The next one is the next part is the IMU. Okay, inertial measurement units. Okay, this inertial measurement unit, it consists again. These are used, or we can say that these devices is used to find the position of an object with the help of different, we can say that like with the help of accelerometer, gyroscope. With the help of that we can find the position of any object. Now we'll discuss on inertial measurement unit. It is a short form of that is IMU. Is a device that integrate multi-axis like accelerometer, gyroscope, and other sensor to provide estimation of an object orientation in space. Means to define like our GPS. Okay, similarly, IMU are used to define the position of any object in the space or environment. Okay, एखाद्या environment मधला एखाद्या स्पेसिफिक ऑब्जेक्टचे ज्या पद्धतीने जीपीएसच्या साहाय्याने आपण डिफाईन करू शकतो longitude and latitude. Similarly, we can, with the help of this inertial measurement unit, we can use define the position of any object. And position of a object, it is defined with some integrated parts like accelerometer, a gyroscope, and the magnetometer. Okay, with the help of that one, okay, we can define the any object or the orientation in the space of any object. Now, how actually, what is the function of accelerometer, gyroscope, and the magnetometer? Might be you know. Okay, accelerometer, it will show the, or simply you know the acceleration. Acceleration is nothing but we can say that change in velocity with respect to time. Okay, the any object, the velocity of that object with respect to time we can check with the help of this accelerometer. And what is the function of gyroscope? To find the angular movement of any object we need gyroscope. Okay, mostly probably might be you know gyroscopes are used in aeroplanes. Okay, might be you have studied in theory of machine. You find that position or the gyroscope position we need this, or that plane position we need this gyroscopes. And magnetometer, and we have seen in magnetometer it is similar function of our Hall effect. Okay, in that we have seen if you place the one permanent magnet above the one metallic plate, okay, from that metallic plate if the electrons are moving, it will be separated with the help of that magnet. And with the help of that we can measure the velocity of the object or the voltage, and that voltage is converted into the velocity. Okay, with the help of that three elements, this inertial measurement unit is working. Okay, depend upon that three components. Which are those three components? Accelerometer, gyroscope, and the one more is the magnetometer. Okay, with the help of that one, depend upon that three components, our inertial measurement units works. Now next one, measurement of acceleration, angular rate, altitude are typically data output. Okay, means acceleration we can measure and we can record that one. Next, angular rate also we can measure, angular velocity, angular acceleration we can measure. Might be you have studied in the theory of machine how to measure angular velocity, and which is recorded and depend upon angular velocity, velocity of object, okay, and altitude we can find the object position in the space. Okay, त्या ऑब्जेक्टची पोझिशन किंवा ओरिएंटेशन आपण त्या ठिकाणी फाइंड आउट करू शकतो. Next, microstrains IMU inertial sensor are commonly used in robot dynamic motion and compensation, payload platform stabilization, and antenna camera pointing applications. Okay, for payloads and platform stabilization, we need such kinds of the accelerometer or the this inertial measurement units or the antenna or camera we need. Next, IMU reports data related to orientation, velocity, gravity, depending on which sensor are involved. This data is important for vehicle, for or aircraft, or simply tracking this data for some other purpose. Okay, for a tracking of any object, we need this IMU. Again, we can say that aircraft, vehicles, we need this, okay, inertial measurement unit. Next one is the, for instance, an unmanned aircraft such as drone utilize IMU for reporting data to the operator or automating certain functionality with the assistance of the computer. A traveling robot may use a IMU to track its orientation velocity at any given time. Next, most IMU that you will find on the market consist of an accelerometer, gyroscope, and magnetometer. Such as IMU are said to have 9 degree of freedom. Might be you know degree of freedom means number of, okay, motion that object can perform. Okay, that is nothing but we can say that a degree of freedom. Okay, if you take the robot arm we can develop with 2 degree of, 3 degree of, 4 degree, means the movement of arm depend upon the degree of freedom. If the arm will move the along x, y, and z axis, then that robot it is known as the 3 degree of freedom. If that robot move along x, y, z, as well as it will rotate along x, y, and z direction, then it is known as the 6th degree of freedom. Okay, and if it having the angular movement with respect to each other, then we can say that that robot arm having 9 degree of freedom. And you will find the best example of 3 degree of freedom in our 3D printing machine. Okay, might be you have seen 3D printing machine. In that you will get the this inertial measurement units, and in that you will find the accelerometer, gyroscope, and magnetometer. Next, degree of freedom in the context of an IMU basically refers to a fact that IMU will report 9 different values. Means this will report 9 different values like along x, along y, and along z direction. The accelerometer reports the acceleration forces along x, y, and z axis of IMU, and the gyroscope reports the angular acceleration around the x, y, and z axis of the IMU. Okay, next, and the magnetometer reports the strength of the current magnetic field on the x, y, and z axis of the inertial measurement unit. Next, between 3 sensors, you get 9 reading, hence the 9 degree of freedom. Means with the help of accelerometer, you will get acceleration force along x, y, z. Gyroscope, you will get the angular acceleration along x, y, z, and magnetometer you will get the current magnetic field along XYZ. Okay, from with the help of three axes, these three axes and these below three axes means angular acceleration XYZ, acceleration force along XYZ, and magnetic current field along XYZ. Means these three and 9 degree of freedoms you will get with the help of this inertial measurement. Also, this inertial measurement, it is working on same principle of our GPS. Okay, in that also there are three satellites. Depend upon that three satellites only, it will capture that image or object, and that object positions are defined. Okay, now we will see how actually it's work. कसं वर्क होते हे बघूया आपण.
Hello viewers, if you are interested in making an IMU, inertial measurement unit, then this video will help you to make it successful. Purpose of IMU is to measure a specific force on a body or its rotational motion or sometimes its orientation. It is the main component of inertial navigation system used in aircrafts, drones, and in many. To make the IMU, we need a combination of sensors like accelerometer, gyroscope, and magnetometer. These combinational sensors are also called IMU sensors. Why to use these sensors in combination? As each sensor alone have uncertainty in measurement. Unfortunately, all these sensors have different problems. By combining these sensors, one will compensate the problem of other. That's where the sensor fusion comes. We will discuss it in detail in the next video. Thanks for watching this video. Hello viewers, if you are interested in making an IMU, inertial measurement unit, then this video will help you to make it successful. Purpose of IMU.
First, let's briefly explain how each of these microelectromechanical systems or MEMS sensor
Okay,
work.
you will
We
find
will start
these
with
are
the
the
accelerometer. It measures acceleration by measuring change in capacitance. Its microstructure looks something like this. It has a mass attached to a spring, which is confined to move along one direction and fixed outer plates. So when an acceleration in the particular direction will be applied, the mass will move and the capacitance between the plates and the mass will change. This change in capacitance will be measured, processed, and it will correspond to a particular acceleration value. Next is the gyroscope, which measures angular rate using the Coriolis effect when a mass is moving in a particular direction with a particular velocity, and when an external angular rate will be applied, as shown with the green arrow, a force will occur, as shown with the blue
you
arrow,
will get
which
here
will cause perpendicular displacement of the
three
mass. So similar
movements
to
in
the
gyroscope.
accelerometer, this displacement will cause change in capacitance, which will be measured, processed, and it will correspond to a particular angular rate. The microstructure of the gyroscope looks something like this: a mass that is constantly moving or oscillating, and when an external angular rate will be applied, a flexible part of the mass will move and make the perpendicular displacement. Okay, now let's explain how the magnetometer works. It measures the Earth magnetic field by using Hall effect or magnetoresistive effect. Actually, almost 90% of the sensors on the market use the Hall effect, and here's how it works. If we have a conductive plate like this and we set current to flow through it, the electrons would flow straight from one to the other side of the plate. Now, if we bring some magnetic field near the plate, we would disturb the straight flow and the electrons would deflect to one side of the plate and the positive poles to the other side of the plate. This means that if we put a meter now between these two sides, we will get some voltage which depends from the magnetic field strength and its direction. The other 10% of the sensors on the market use the magnetoresistive effect. These sensors use materials that are sensitive to magnetic field. usually composed of iron and nickel. So when these materials are exposed to magnetic field,
I hope you understood that.
Monica, I just sent you the email with the client
Looking at the
notes.
doc now, but I think it's an older version. Can you send an updated?
Monica, check your messages when you can.
Okay. Just you remember that these are inertial measurement units are used to find the object position in the space or the orientation of the object in the space with the help of the gyroscope, magnetometer, and accelerometer. Okay, by providing the 9 degree of freedom. Next one is the global positioning system. Might be you are using GPS system for the map. Okay, how it is working, that GPS positioning system? Now we will discuss. Might be this global positioning system helpful us to find where we are and where we are going. Okay, might be we know, okay, in maps where when we on the GPS, okay, it will tracked with hello, am I audible? आवाज येतोय का? Hello.
Yes, sir.
Audible, no? Okay. This GPS are used, कशासाठी use करतो आपण? To find, okay, where we are and where we are going. In map, might be you have seen, okay, when we on the GPS, we will know the exact position of our mobile. And how it is done? With the help of the satellite. Okay, with the help of satellites, that GPS one signal is connected with satellite, and depend upon the satellite, it will provide the information of our longitude and altitude. Okay, longitude, altitude. Okay, these information is provided with the help of that GPS. If that if we are moving further, that position of longitude and latitude are changing and depend upon the, it will guide us. Okay, आता प्रत्येक वेळेस काय असणार आहे, तर एक पाथ असेल तर त्याचे रूट असेल तर त्या ठिकाणी लॉन्जिट्यूड लॅटिट्यूड त्याचे सेम असणार आहे ग्लोबल पोझिशनिंग सिस्टीम मध्ये. अँड डिपेंड अपॉन दॅट, ओके, इट विल फॉलो द path and we will reach to certain place. Okay, त्या ठिकाणी आपण एखाद्या स्पेसिफिक पोझिशन वरती जाऊ शकतो. But in the GPS, to define or the find the position of any object, in there are 3 satellites are used to define the position of any object. Means 3 satellites will pass the signal and it will find the accurate position of any object. ओके, एखाद्या ऑब्जेक्टची पोझिशन फाइंड आउट करायची असेल तर एका सॅटेलाइटच्या थ्रू सिग्नल पास केला जाणार नाही, तर त्या ठिकाणी वेगवेगळ्या सॅटेलाइट 3 वेगवेगळ्या सॅटेलाइट थ्रू त्या ठिकाणी काय केलं जाणार आहे, तर सिग्नल पास केला जाईल. अँड डिपेंड अपॉन दॅट 3 सॅटेलाइट, इट विल डिफाइन द position of any object. Okay, now we will move. This GPS are mainly used in our robots. Okay, in which robots? कुठले robots use करणार आहे, तर in cobots or the AGVs, automatic guided vehicles. Okay, जे काय आहेत तर त्यामध्ये आपल्याला GPS हे युनिट इन्स्टॉल करणं गरजेचं आहे. Okay, means it will define the position and it will easily locate the position of that accordingly longitude and latitude. Okay, we can easily find that robot position. Okay, they can also do the same for robot which would have impact on field from manufacturing to agriculture. Means we can use this everywhere. Might be you have seen In manufacturing sector also, we can use AGVs, which is guided with this GPS. And in agriculture also, okay, might be you have seen in tractors or the other digging machines or the agriculture machines, you will find the some of the GPS are used inside of that. Okay, that GPS will define the position of the object. The global position system is made possible by a group of satellites in Earth's orbit. The of satellite transmit precise signal, allowing GPS receiver on the ground to calculate and display location information to user. This GPS is owned by the United States. Okay, previously this GPS are used only United States. They have first built this GPS for the military purpose only. That United States they have prepared this GPS and they are using for military purpose. And after some days, okay, they have used it for the common for all users. Okay, common for all users. By capturing the signals from satellite, GPS receivers are able to use mathematical principles to pinpoint geographic location. With the addition of computing power and memory, such as the road maps, points of interest, or topographic information, GPS receivers are able to convert location, speed, and time information into a useful display format. Means it will collect the information, and if you see in our mobile, there is one assistant device. Due to that assistant device, that easily it will track the device, but in the vehicles there is no assistant device. Okay, it will take some time to define the position of that object, but in satellite our mobile, it is easy or the easily it will detect the position due to that assistant device. That assistant device easily send the signals to the GPS or satellites and it will receive, and that assistant device will guide us to where we should travel. Next, advantages and some limitations of this GPS. Which are the advantages? Works accurately in all weather condition, around the clock, around the globe. Okay, where you should go. Okay, the GPS will define same longitude and altitude at that position. Okay, it does not change with weather condition also, means whether it is the rainy or the winter season. Okay, it does not change the position. No subscription fee to use a GPS signals. There is no fee for this GPS signals. Okay, and to cover whole world, it required near about 33 satellites around our uh, Earth. Okay, if 33 satellites are there, then easily we can cover all global positioning system or the GPS signals we can pass through all over. Okay, that America has sent near about 70 to 75 satellites, GPS satellites, and in that only they have it is used. Amol Mari, you have any problem? Why you have written roll number? I will mark absent now. Huh? You are writing if early. I have not declared yet. Lecture is over. Okay. Those are writing. We generally accurate within 50 meters. Models with wide area augmentation system signal are accurate within 3 meters. Okay. Some of the limitations may be blocked by dense forest. Okay, does not work well in indoor underground spaces. Satellite maintenance, radio interference, solar storms can cause coverage of gaps. Okay, due to these are satellites mounted in the space. Due to that, okay, some solar storms or the some of the radio frequency. Due to that, some changes may occur. Okay, these are the some advantages and limitations. Let's we'll see this video how actually work and we'll end today's session.
रणवीर सर आया
नमस्कार दोस्तों, आपका स्वागत है हमारे YouTube चैनल ICA टेक में। आज टेक्नोलॉजी इतनी ज्यादा बढ़ गई है कि जिससे हम अपने सारे काम ऑनलाइन ही मोबाइल पर कर सकते हैं। आज सभी स्मार्टफोन यूजर इन टेक्नोलॉजी का उपयोग करते हैं और इन्हीं में से एक है जीपीएस। आपने भी अपने मोबाइल में कभी जीपीएस का इस्तेमाल किया ही होगा या आपने गूगल मैप्स में जीपीएस का इस्तेमाल किया होगा। तो आइए दोस्तों, आज हम सब जानते हैं कि जीपीएस क्या होता है और कैसे काम करता है। अगर आप इसकी पूरी जानकारी प्राप्त करना चाहते हैं तो इस वीडियो को शुरू से लेकर अंत तक जरूर देखिए, आपको जीपीएस की सारी जानकारी मिल जाएगी। तो चलिए शुरू करते हैं। जीपीएस की फुल फॉर्म होती है ग्लोबल पोजिशनिंग सिस्टम। जीपीएस एक ग्लोबल नेविगेशन सैटेलाइट सिस्टम है जो किसी भी चीज की लोकेशन पता करने के लिए इस्तेमाल किया जाता है। इस सिस्टम को सबसे पहले अमेरिका के डिफेंस डिपार्टमेंट ने 1960 में बनाया था। उस समय यह सिस्टम सिर्फ यूएस आर्मी के इस्तेमाल के लिए बनाया गया था। बाद में 27 अप्रैल 1995 में यह सभी के लिए बनाया गया और आज हमें यह हमारे मोबाइल में भी देखने को मिलता है। और इस टेक्नोलॉजी का सबसे ज्यादा इस्तेमाल नेविगेशन यानी कि रास्ता ढूंढने में किया जाता है। अब ये टेक्नोलॉजी इतनी ज्यादा इस्तेमाल होती है कि इसे आप अपने मोबाइल में, हवाई जहाज में, रेल में, बस में, यहाँ तक कि गाड़ियों में भी इसका इस्तेमाल होता है। जैसे कि मैंने बताया था कि इसका इस्तेमाल रास्ता ढूंढने में ज्यादा होता है, इसीलिए ट्रांसपोर्ट में इसका इस्तेमाल सबसे ज्यादा होता है। इसकी मदद से हम कहीं भी रास्ता बड़ी आसानी से पता कर सकते हैं। तो सबसे पहले जीपीएस को 3 सेगमेंट्स में डिवाइड कर दिया गया है। सबसे पहले आता है स्पेस सेगमेंट यानी कि जीपीएस सैटेलाइट्स जो पृथ्वी के चारों ओर घूमती हैं और यूजर तक डाटा भेजती हैं। दूसरा सेगमेंट आता है कंट्रोल सेगमेंट यानी कि ग्राउंड कंट्रोल स्टेशन। ग्राउंड कंट्रोल स्टेशन से जीपीएस सैटेलाइट पॉइंटर होती हैं। और तीसरा और मेन सेगमेंट होता है यूजर सेगमेंट यानी कि जीपीएस रिसीवर्स जो सिग्नल्स को हमारे डिवाइसेस में रिसीव करता है और इसी से हम पता लगाते हैं कि हमारी लोकेशन कहाँ है। तो ये तो थी सेगमेंट्स की बात। तो अब हम बात करते हैं कि अब जीपीएस काम कैसे करता है। तो जैसे कि आपको पता है कि जीपीएस सैटेलाइट की मदद से काम करता है, जिसके लिए अमेरिका ने 50 से भी ज्यादा जीपीएस सैटेलाइट्स लॉन्च किए हैं। वह सैटेलाइट्स 24 घंटे पृथ्वी पर सिग्नल भेजती रहती हैं। उन सिग्नल्स को रिसीव करने के लिए हमें एक जीपीएस रिसीवर की जरूरत पड़ती है। जीपीएस रिसीवर लोकेशन का अनुमान पृथ्वी के ऊपर घूमने वाले सैटेलाइट्स के समूह द्वारा भेजे जाने वाले सिग्नल के आधार पर करता है। हर एक सैटेलाइट 24 घंटे सिग्नल भेजता रहता है। रिसीवर उन सिग्नल्स का टाइम और उस सैटेलाइट्स का डिस्टेंस भी रिसीव करती है। रिसीवर बेहतर परिणाम के लिए 4 सैटेलाइट का उपयोग करती है, जिससे यूजर की डायमेंशन, पोजीशन यानी कि लैटिट्यूड, लॉन्गिट्यूड और एल्टीट्यूड पता लगता है। एक बार जीपीएस सिस्टम को जीपीएस डिवाइसेस का लोकेशन पता करने के बाद वह डिवाइसेस की अन्य जानकारी भी ढूंढता रहता है, जैसे कि उसकी स्पीड, उसका ट्रैक, उसका ट्रिप, उसकी दूरी और उसकी जगह कौन सी है और उसकी जगह से दूरी कितनी है, सूर्य उगने से लेकर सूर्य के। इसको हम आपको एक एग्जांपल देके बताते हैं। कल्पना कीजिए कि आप पृथ्वी पर कहीं खड़े हैं।
Okay, time is over. Now we'll see a remaining video next one, next lecture. If you have any problem, you can ask. Otherwise, you can write your roll number in chat box. We'll end today's session. You can leave the meeting, no problem. You can write your roll numbers in chat box and you can leave the meeting, no problem. You can write your roll numbers and you can leave the meeting.
Okay.